So you're chasing an electrical issue on your car. Maybe a window won't work, you've got a fuse that keeps blowing, a light won't turn on, or your horn doesn't honk. So you grab that test light, maybe even your multimeter, but is that the fastest way? I don't really think so. Enter this power probe. This thing instantly tells you if a wire has power or ground. It lets you activate components on the spot, trace shorts, and verify circuits without jumper wires or that back and forth tool switching. It's like a voltmeter, a switch, and a jumper wire all in one hand. Now I've been using this in my shops for many years since the release of the original power probe, and it saved me hundreds of hours on real-world diagnostics and repairs. In this video, I'll show you exactly how the power probe works, when you should use it, and when not to test a circuit with it, and how it can make you diagnose electrical problems faster and smarter. If you're still diagnosing stuff the old way, you'll want one of these tools. I want to talk about the power probe and what makes it different than a test light, what makes it different than a multimeter, and how you can use this tool in your everyday life. I can't live without this thing. This is literally probably my favorite diagnostic tool. It's better than a scan tool. It's better than anything out there. If you're chasing electrical problems, this is the go-to. This is where we start with any system, checking for grounds, checking for powers. It helps you diagnose problems with electrical motors, with solenoids, all types of things. I'm going to give you a couple of demonstrations here how you can use this thing to your advantage when you're trying to diagnose an electrical circuit, a problem with a component, or testing a component itself even. So this is the way this thing is different from a multimeter. This multimeter here is going to tell us if we've got power. We might be able to do a voltage drop across a ground circuit and see if we're losing some voltage through a bad connection somewhere. But it won't allow us to activate things, and that's the core function of the power probe. It's allowing us to supply battery voltage to a component and see how it responds. Does it work? We can also use it to run a motor up and down. And with flipping the ground circuit and the power circuit, we can run it up and down in both directions by changing that polarity. So we can activate horns. It's got a built-in circuit breaker, which is nice. If you overload a circuit, if a circuit's got a short, and it'll pop the breaker and you're not going to burn anything to the ground. Now it has some limitations as well, especially the older versions. Version like this one, the Power Probe 3, it allows you to check voltage. It gives you some continuity checks and some things, but it's not as advanced as this Power Probe 4. You're not checking more in-depth computer circuits really, so you need to kind of stay away from where you apply power on this thing, where you apply ground. You have to be really careful with modern computers and electronics, but if we're working on basic 12-volt systems, we're not working on pulse width modulated systems and those things, this Power Probe 3 or even the older versions are just perfect for that. They're great for all the 12-volt high current systems that we're working on these cars, like horns, lights, wipers, you know, any of that stuff. You're going to have no problem diagnosing that stuff with this tool. It's a great tool for those things. So let me show you a couple of the features on that. If you guys are interested in this Power Probe tool and what it can do, more advanced tools like the Power Probe 4, we can get into that in another video. You guys got to let me know down in the comments. I don't want to get over anybody's head with diagnostic things. I want to get you guys the core basics that you need, and this tool will get you very far with just the older version. You could even go back to, if you could find a Power Probe 1 or 2 somewhere used, great tool to have in your arsenal. And I know I'm not promoting Power Probe by any means. There's other great tools that have copied Power Probe that are out there now. Maybe Launch and some of these other tools make one as well. So just the thing you need to take away from this video, this tool is really great for diagnosing all those things we talked about. And let's get into this and show you a few features. All right, before I hook this up, I just want to let you know we really only got 2 leads for this. I apologize, I've got the little electrical tape on here. This one's a little beat up. That's why I've got my new one over there, but I wanted to show you the core functions of this. I've got an alligator clip for power and ground. We can just connect these to the battery. So battery positive, battery negative. And once we do that, you heard the tool light up. A couple of lights lit up. It's got a light here for ground and one for power. It's got a couple of lights to help you see underneath the dashboard and a fuse box. It's got a replaceable tip on it. If your tip should get worn out, and there's other adapters you can put in here with this banana jack they've got inside the hole there. And then we've got the button on here, the rocker switch. This rocker switch on these power probes is just supplying power to the tip. So if I press the power button, you can see it lights up. It's showing us it's sending power out of the power probe from the battery into the tip of the tool. So wherever you place that, you're going to get power. I've got ground on this side. Same thing. If I want to ground a circuit All I have to do is press it down and hit ground. It's showing you it's grounding, and it's going to send ground to the tip. In the neutral position, I've got nothing other than testing. So I can stick it on 12 volts. There's a little voltmeter here that's showing me it's got 12 volts on there. And then I've got the ground side, it's showing me 0 volts. Okay, that means that's pretty much my voltage drop to ground circuit. Okay, 0 volts. You saw on here as well that I've got a couple other buttons. This one here is to turn the sound off. So I find this sound is useful. If you're underneath the dashboard and you're checking some fuses, it's nice to be able to hear that voltage or hear a ground. You see how they have a different tone to them. Okay, that's ground and power. So it's nice to be able to hear that if you can't see the screen on here. Now, some of the newer power probes have made the screen bigger. They've made the display nicer, easier to read, the colors inside them. So they've made a lot of advancements to the power probe. The original power probe didn't even have a voltmeter on it. There was nothing there. All you had was the rocker switch and a breaker and the sound button. So turn the sound on and off as you need. If it's annoying you, you can do that. And then the last button on here is the breaker switch. So if you're applying power to something that is already grounded and there's no load in the circuit, well, we've just essentially created a short circuit with the tool. We got power straight to ground, no load in the circuit, it's going to pop a breaker. So this tool has a built-in breaker for it. If I go straight with my tip to the negative of the battery and I supply battery power to it, 12 volts, you heard it pop the breaker there, or maybe you didn't hear it. Let me do it again with the sound off so you can hear it. So I'm at the negative of the battery. I'm going to supply power to it, and you could hear that click. That's the breaker popping in there. So this has also got built-in protection for your circuit and for your tool, okay? Now what you don't want to do is go in here and start powering up computerized circuits when you don't know what these circuits do. There are a lot of components inside modern electronics, inside circuit boards and things, and you send 12 volts to that circuit and you're going to do some damage to it. Those systems are not designed to carry 12 volts. That's what this tool is supplying. So it's really important when you're using this tool, you understand what electrical circuit you're working on. If you're going to apply power to something, you better be sure that you know where that circuit is supposed to be going or where it's coming from. Okay, so we know when we're sending power down the line that we know it's actually a 12 volt circuit, and whatever we're sending it to is capable of receiving that signal. And I would say the same thing for a ground circuit. So you don't want to be grounding something that's got a power supply coming out of the computer or something. It's not a good idea either. So this is where you need to be careful with the power probe. In the right hands, it's a very valuable tool. In the wrong hands, you could do some damage with it. So be extremely careful when you're testing circuits and know what you're doing. If you have to check something, maybe remove a component or something. I'm going to show you how we do that on a solenoid here too, so you can understand how you could check a solenoid with it. So let's get into the first use of this, the most common use, and that's just checking for power in a fuse box, let's say. So I've got a fuse box here, same as we did on the battery. Oops, we don't need that, I guess. Same as we did on the battery, we're going to put it on the battery. I'm going to turn this beeper on so you guys can hear, but 12 volts is going to sound like this. So we could go through our fuses and we could check both sides of each terminal. And I discussed this in, I should probably turn a key on for you guys. All right, so here's a fuse, a 30 amp fuse that has 12 volts to both sides, okay? But I don't even have the key on in this car. So a couple of things, probably getting off on a tangent here, but if we're looking at fuses with a tool like this and we're checking both sides, and I've got power to both sides, that usually means that I've got a good fuse and that circuit is hot right now. Okay, now I'm checking some of these other fuses, like over here, and nothing happens. Okay, it means there's no ground anywhere because the ground didn't light up, the green didn't beep in that different tone. Okay, and it just means the circuit's not hot right now, so we would probably have to turn a key on or a relay has to engage in order to send power to this fuse. So it's important you know what you're checking. I did a video on that using the multimeter, so if you guys need to watch that, you can. If you want to know more about testing fuses with a multimeter or even with a power probe, it's important you know what you're looking at. So again, here's another circuit. I've got power on both sides of each of these fuses, and if I go down the line, it's a really quick way to check your fuses and make sure the fuses are good. If I had power on one side and then it came up this ground on the other side, I've probably got a blown fuse. Quick service reminder, you guys know we love hearing from you in the comments. I like to go in there and answer as many of your comments as I can. I want to see what you guys are interested in. I like to get your thoughts. I'm learning from you people as well as you guys are learning from me. I love this interaction. I think it's great for us. It certainly helps our channel grow as well. Don't forget to like, subscribe, share this video with people you think that can use this information. We're putting this content out for you guys to help you make your life a little bit easier and help you navigate the auto repair world. So thanks for following along with us, and let's get back to the video. So let me give you another example of how we can use this power probe to help us diagnose a problem. I've got here on this air ductwork attached to that is the evaporative emission system purge valve. That purge valve gets a 12 volt in the ground, so we know we can activate that system with the power probe safely. So what I want to do is I'm just going to pull this out. I'm going to show you how I activate it with the power probe. I've also got a piece of hose here with me and show you how I would see to make sure it's sealing. The valve actually seals when it's turned off and how it opens when it's turned on. Okay, so let's pull this out real quick and show you what this looks like. All right, so I've got our valve here. It's got two hoses on it, and it's got two wires at the connector. So I'll just stick this hose on one end. The other one I'm going to just try to blow through while I activate this solenoid with the tool. So I should probably mention here that this tool has an extra lead hanging off of it. Okay, so we talked about all the features on here, but it has this lead that's dangling. Well, what this lead is actually a ground circuit. Okay, so let me turn my sound on. And if I connect the ground circuit to the tip of the probe, it's telling me it's a ground circuit, just as if our battery is a ground at the negative, just as if our chassis is a ground at the top of this strut tower, just as if our engine is ground. Okay, everything leads back to the negative of the battery. It's all part of the 12 volt negative ground system. Okay, so this is giving me that ground circuit. So I can use this as a ground side wire to complete the circuit. I can use the tip of the power probe as the power. And I'm going to put these both on these two terminals of this solenoid, and we should be able to activate it with the power probe. So you just want to be careful you don't touch the terminals together. And there's one more feature which is kind of neat about this tool. The new ones are even better. But this one is actually a continuity checker as well. So we know inside this solenoid is a coil of wire. And that coil of wire has got to have continuity in it, right? It's got to get from one terminal to the other. So when I just touch this to one terminal while I have that ground lead clipped on the other, we can see that we've got continuity on there. Okay, so it's showing you that because it's seeing the ground, it's picking up the ground terminal that we've got connected with that little alligator clip. Okay, so this is a good way to test to see if your solenoid has even got an open circuit or not. Okay, now that's not giving you a resistance reading. If this solenoid was supposed to be at 36 ohms, it's not going to tell you that with this power probe. Okay, but it is going to tell you if it's got continuity, if there's an open circuit in it. So that's one test you can do there. And then the next thing we're going to do is we're going to activate this. So I'm going to turn this beeper off, the buzzer, so you can hear possibly the solenoid clicking as I supply power to it. I've got ground on one terminal, power on the other, and I'm activating it. And you can feel it clicking. You can hear it clicking. The next step is to see is the valve, the mechanical portion of the valve, is that working? So we're testing the electrical portion right now, but I want to check the mechanical at the same time. So what I'm going to do, I'm going to blow this. Okay, now this looks weird. Don't fault me for that, but I just wanted to show you that we can easily test the mechanical portion of this valve to make sure the valve is opening completely and closing completely and sealing off. Okay, I'm trying to blow through that valve on the actual EVAP lines there. Okay, so we're activating the solenoid and we're watching it turn on and off, and we're feeling it turn on and off by blowing through it. So this is just one example of a test that you can do with this power probe. Now, we could also come in here and we could back probe this and check these wires at the harness if we wanted to, and use it more like a voltmeter. We could see, are we getting our signal from the computer to the purge valve, and are we getting a ground circuit to the purge valve? Okay, we could test both of those with the tip of this power probe as well. Okay, so I'm setting up another example here of how you might use this tool, and we're going to be testing a horn circuit on here. Now, it's important when you're working on a horn circuit, you understand how it works. So I'll briefly talk about that, and then we're going to test it for you. So the average horn circuit, we just need power, 12 volt supply, and we need a ground to make the horn honk. But how that's accomplished changes depending on the manufacturer of the car. Some manufacturers, they control the ground side of the horn circuit. Some control the power side of the horn circuit. When I see a single wire horn like this one, I'm feeling pretty confident it's only going to be a power side control circuit. So we honk that horn, we're sending power to the horn. If we had two wire, it could be something different, but you need to determine that with your wiring schematic or using some other methods here. So, but what I want to show you is how you could easily test the horn in the horn circuit. So a couple things we can do. One, I back probe this horn, and you can see it's showing we have ground. Now what that's telling me is that we have some continuity through the horn. The horn is similar to that solenoid we talked about earlier, where it has a coil of wire in there that has to do the work. That's the load of the circuit. And what's happening is telling me that we have continuity to ground. If I were to disconnect this, so we have a single wire sensor, this is going to be our voltage, our battery voltage, and the ground side is through this bracketry at the back of the horn to the chassis all the way back to the negative. If I were to look at this and I had a bad ground circuit, I'll show you what it would look like. I remove the ground. As I said, it's grounding through this terminal, this strap, to the radiator support and all the way back to the battery. Now if I do that same test, you saw it lit up green before, and I back probe it now, I have nothing. That means the ground circuit is not there. There's no continuity between this terminal through the horn windings, through the strap, back to ground. Okay, so I would want to look at the ground circuit probably. Okay, I'm going to show you another test we can do with this. I'll show you a couple of tests we can do with this. So another thing you could do, let's say you just wanted to see if the horn was bad. We're not worried about the wiring right now. Okay, we've got a single terminal here at the horn. We know we've got ground here, and I've told you what this power probe can do. This has an alligator clip that's ground, so we can put this on the ground side of the circuit, okay, grounding through here, and then we can supply power to it, and the horn should honk, okay? So again, see how now I get back in the terminal, I have that ground circuit completed because I've created the ground with the ground side of the power probe. Okay, now all I have to do is put some power to it, it should honk. Okay, so a simple test if you wanted to see if there was a problem with the horn or the control side of it. There's one easy test for you, okay? Again, it's important to know what type of circuit you're working with. If it's got two wires or a single wire. Some cars have two horns, high and a low. Okay, a lot of cars have two horns, so it's important you know what you're working on, what you're looking at. So there's an example of that. And then another thing we can do is we can test the signal to the horn. Okay, so that's easy enough to do. We can either put this back on and back probe it, or we can just back probe the wire by itself. So we've got this wire here. We can back probe that, and then I'll go honk the horn, and it should light up red. Let's go press the button. Okay, so I honked the horn 3 times in a row. We got 3 power cycles on there. We know we've got power for the horn circuit to the horn. So if your horn wasn't working and you didn't pull it out and check it with the power probe, it's one way to do it. You would check the control side of it, and we say, okay, everything's good on that side of the circuit. There's nothing else we need to do. I don't even need to check a fuse. We know the fuse is good. Everything is good. Check the horn pad, the wiring in the steering column, all of those things will be testing good if you just check it right there. So this is one way to eliminate a lot of time diagnosing a problem using a power probe. I mean, like, this is my go-to for just about everything electrical. It's my favorite tool probably. I told you that already. It saves a lot of time. I didn't even need to check the horn circuit fuse. No need to even find it in the car. It doesn't matter where it's at. I know I've got power in the horn circuit. That's fine. So if the horn wasn't honking at this point, I would say, well, I've probably got a bad horn on there. Now I could take it one step further and test that horn individually like we just did. If it didn't honk, we know the horn is bad. So there's another example for you. Here's another simple test. Let's say you had a headlight out over here. I've got the headlights turned on. This one's not illuminating. That one is. Maybe we want to check the circuit, make sure we've got power and a ground. I've unplugged the headlight bulb here. It's only 2 wires. Okay, we can check the power side. We see we've got 12.2 volts, and we check the ground side, 0.1 volt. Okay, so we've got a good ground circuit, we've got a good power circuit. If I were testing that right now, I don't need to check the headlight fuse or anything. I already know this headlight bulb is going to be bad because it's got its power source and its ground source. It's just that simple. No headlight relays need to be tested or anything. Let me give you another simple example of how you can use this power probe. I've pulled a relay here out of the fuse and relay box under the hood. It's just a simple 4-pin relay. I guess quickly let me just tell you how a relay works if you don't understand. A relay is just a switch. It uses a low current circuit to control a high current circuit. So let's say we've got a cooling fan relay, and the cooling fan draws 25 amps. Well, we don't want to use the computer to run 25 amps through the computer to the cooling fan. So what we'll do is we'll use the computer circuit on the low current side to turn on and off the relay. and then we'll use the high current side of the relay to pass all that high current through the 25 amps. So this is carrying low current and high current. Now if we're looking at these terminals, there's a couple of small terminals and a couple of big terminals. Well, the big terminals are obviously the high current terminals. Okay, so it's easy to determine on this one. You might not see that on every relay, but on this one it's fairly obvious. The terminals are numbered also, so if you look at the wiring schematic, you can just match up the numbers in the wiring schematic. I'm just going to give you this simple test now. We're going to put the ground circuit on the low current side. We're going to use the power probe to activate the relay. And then I've got a multimeter set up here in the ohm setting. And what I want to see is I want to see this switch contacts close, and I want to see it passing continuity from the big terminal to the other big terminal. Okay, so right now you can see I've got an open circuit between the two big terminals. Okay, and that's because that relay is turned off. And once I turn the relay on with my power probe, okay, we're going to see that ohm meter, it should go to 0. We should have continuity going across the two blades on the high current side. So I'll go ahead and turn this on. And if you look at our ohm meter, we're at 0.13 ohms. Okay, we've got continuity through the relay. Everything is working on there. Okay, so if you were to do that, you could say, well, I know that relay is good, but why isn't it working? And why am I not getting power to the fan? Maybe there's something else going on. You know, this would be a good example where we might need to actually check the fuse. Might need to check the control side from the computer, see if it's turning the relay on. There's going to be 2 power supplies here to this relay, and then we've got 2 ground sides, or I should say 1 returning to the load and 1 ground side for the computer control. So again, just a quick test on a relay if you wanted to check one like that using the power probe. Well, there you have it. There's your introduction to the power probe and how it can be useful to you in your diagnostic world. I prefer this over a test light for the obvious reasons that we can supply power, supply ground, we can check power, check ground. We can also, you'll see on this Power Probe 3, it has a voltmeter built in. If I didn't have 12 volts, if I had 9 volts or 10 volts, my voltage was low, it would tell me that in addition to the beeping red light. The original Power Probe just had a red light, green light, there was no voltage meter on it. So that helps a little bit. And I showed you an example of how to check continuity, whether checking ground continuity or continuity through a device, through the load side of the device. You can use this in that way with that extra ground lead supplied. So this is a super valuable tool, and I hope if you guys don't own one and you're doing this kind of work, you should have one. I encourage all my technicians to have it and use it and know how to use it. It just saves a ton of time pinpointing electrical problems quickly, because we're testing an entire circuit with one tool, and we can test it usually right at the load source, which is really nice. So I hope you find this valuable. If you guys are interested in seeing more of what the Power Probe can do, especially this Power Probe 4 that I got up here, or even the newer version of the Power Probe, which does even more, we can certainly make some more videos on those things, but I wanted to get you that introduction and get you away from a test light. If you're checking fuses and things with a test light, or just even for your basic electrical testing, you should have a better tool. I hope you like this stuff, and we'd like to make more for you if you're enjoying it. So thanks for following along, and we'll see you in the next video.